So today we are looking at a question in further mathematics NECO 2026, but we are going to take it gradually. I will have to explain some basic concepts before we solve the question. We have two questions here, question 19 and 20. We have friction in a ladder and vector, addition of vectors. So let's take the number 19 first, friction in a ladder. So let's read what the question says, but before we go there, you need to understand the concept of center of gravity is a point through which the resultant weight of an object is concentrated. So the center of gravity of a uniform body is usually done using a rectangular bar. For a rectangular bar, if you join the two diagonals of the rectangle, where they meet, that is where the center of the body will be placed. That is for a uniform body. So meaning the distance from here to here is the distance from here to here. If here is x, here must be x. So the total length of the bar will be, or the rectangular bar will be 2x. So you need to understand this concept of center of gravity. And we have to have how angles can be inclined to a body. So angle can be inclined either to the vertical or to the horizontal. If you have an inclined surface like this angle is inclined. Here is the y-axis, here is x. This angle here is inclined to the vertical, while this one here is inclined to the horizontal. So these are some of the concepts we're going to look at before we take this question. So let's read what the question says. A uniform ladder of PQ of weight K Newton is hanged at P. Say the ladder is in equilibrium at an angle of 38 degrees to the vertical. Say the horizontal force 8 Newton is at Q. Find the value of K correct to one decimal place. So let's take this one to be a wall. And this is the horizontal ground. Then we have a ladder placed on the wall. And the length of this ladder is not given to us. So let's take it as, let's take the length of the ladder as 2x for instance. Because the weight of the ladder is given to us as K Newton. So the ladder is labeled PQ. The ladder is labeled PQ. So here is point P and here is point Q. So the weight of the ladder will be at the center, which is, let's call it here the center of the ladder now. Of the ladder, let's call the weight K Newton. It simply means from the center to point Q is x, while the center to point P is also x. So the total length will be 2x. Now, if you go back, say the ladder makes an angle of 38 degrees with the vertical. So where is the vertical axis now? Which is this point? Now, the ladder make an angle of 38 degrees with it. Don't forget, here is a right angle. So if you apply the concept of sum of angle in a triangle, let me call your point R first. Here will be 52 degrees. Yeah, that point will be 52 degrees. Let's go back to the question. Say a horizontal force of 8 newtons acts at Q. At Q, so there's a force of 8 Newton that acting at Q. Let's say this is force here, 8 Newton. Okay? Then it said the ladder is hang at P. Meaning at P, the ladder is hung. That means there's a support here at P. So this is the first diagram for the question. So you know what moment is. Moment is the product of force and perpendicular distance. I've done some of the videos on moment. You can go to our YouTube channel and watch them. So this force of 8 Newton, is perpendicular to the wall in this manner. It's perpendicular to the wall in this manner. That means I need to get the distance from Q to R by applying Sukatua. So from Q to R will give us opposite hypotenuse, give us 2x sine 52 degrees. We're going to have 2x sine 62 because the hypotenuse is 2x, the angle is 52 degrees. Then I want you to get the distance of the weight to point P. So let's get the distance of the weight now to point P. Meaning from here to here will be, so if you consider this right hand triangle now, let me call here point T. So if you consider P, T, let me call here V. If you consider P, T, V, you will notice that PV and T is a right angle triangle also. Here will give me, here will produce X cos 52 degrees. So with that, we can now take moment at point P. Let's take moment at P. I will write sum of moments at P is equals to 0. So meaning all forces are heading to P. So this 8 Newton is heading to P, while this K Newton is heading to P also. So by mere looking at it, you know one is clockwise, the other one is anti-clockwise. So what is the clockwise now is the 8 Newton, what's the anti-clockwise? What is the anti-clockwise is 8 Newton, and the clockwise is our K. So we are looking for the value of K. So we have sum of clockwise moments is equals to the sum of anti-clockwise moments. So what is the moment of K now, which is clockwise, is the force of K times the distance of force K to P, which is our X cos 52. So we have K times X cos 52 degrees is equals to, while the force of 8 Newton is perpendicular to our 2x sine 52, which is anti-clockwise. So I'm having 8 times 2x sine 52 degrees. So I'm going to have kx cos 52 is equals to 16x sine 52 degrees. So let me make it the solid formula. My k will give me 16x cos 52 over x sine 52, over x cos 52. So x cancel x, we are left with 16 tan 52, because sine over cos is tan. So if you multiply 16 tan 52, our k will give us 20.47. But to one decimal, we're having 20.5 Newton. That's the value of K, 20.5 Newton. If you go by that, correct option here is A. Number 19 is A. So if you have any questions, you can ask all this Time of Africa. Make sure you like, share, and subscribe. So let's look at question 20. It says simplify using position vector. Simplify using position vector. We have DA, CB, AB, CD. No, question 20 is vector. We have CA minus CB, or in vector form, plus AB plus 2CD. So this is what we have. So in vector, if you have vector AB, can be written as vector B minus vector A. This is how you add a vector. It means vector B minus vector A. So I can rewrite this vector here, this negative vector, I can write it as vector AC, CA. I write it as vector BC to become positive. From minus CB, sent in a positive BC, plus AB plus 2CD. So here I can first of all simplify these two. I'll simplify this too. That will give me, because they have C as a common factor, so my CB plus my CA plus BC can give us AB, vector AB plus, okay, first one is DA. I'm making a mistake already. First one is DA, not CA. So here ought to be DA from the question. Here's DA. So that part is DA, that means we need to rewrite this. So we are having DA, here can be written as BC, then AB plus 2CD. Okay? So we can first of all deal with these two by adding these two first. That will give us DA plus BC plus AB. That will give us CA plus 2CD. So you classify, this is B is a common factor, you take CA as the addition. That will give us CA. Then I can also deal with these two, my DA and CA. My DA and CA. So DA and CA will give us vector DC plus vector 2CD. So just as the first one, I can interchange this by writing it as CD, right, which is negative CD plus 2CD. If I add up, then we're going to have CD as our vector, which is option B. So if you like what you are watching, subscribe, like, and share. This is Time of Africa. We deal with a lot of things. We are into technical drawing, physics, chemistry, further maths, mathematics, computer science, and AutoCAD. So subscribe, like, and share. See you in our next video.